Time complexity answers one question. As the input size n grows, how does the number of operations grow? We don't guess, we read it directly from the code structure piece by piece. Look at this for loop. It runs once for each element in the array. 10 elements, 10 iterations. 1,000,000 elements, 1,000,000 iterations. The count grows in direct proportion to n. We call that linear growth and we write it as O of n. The initial setup, like I equals 0, runs once and gets ignored. A constant added to n doesn't change how fast it grows. Now look inside the loop. One comparison, ARR at I equals target. It's always exactly one step, whether the array has 10 or 10 million elements. When the step count stays fixed no matter what n is, that is the definition of O of 1. Even if there were 5 comparisons instead of 1, we'd still write O of 1. In big O, we only care about growth, constants disappear. This return is outside the loop entirely. It runs at most once, independent of n. Could be the first thing that runs, could be the last, but it's always just one operation. Fixed step count equals O of 1. Now we combine. The loop runs O of n times. Each pass does O of 1 work. Multiply them, O of n. The return outside adds O of 1, but O of n plus O of 1 simplifies to O of n, because for large n the smaller term becomes negligible. Final time complexity, O of n.